look at your hands. I mean, really look at them. Feel the texture of the desk in front of you or the phone right there in your palm. It feels warm, it feels solid, completely, undeniably real, right? But what if? What if this tangible, clay-like reality we're all experiencing is actually just a carefully constructed illusion? What if, right beneath the surface of literally everything you know and love, there isn't physical matter at all, but just cold, calculating digital computation? That brings us to a core existential question, one that has honestly haunted human thought for millennia. Are we living in a computer simulation? And this isn't just some late-night science fiction debate. Ancient philosophers like Plato grappled with this exact same concept in his allegory of the cave, suggesting our perceived world is basically nothing more than shadows projected on a wall. And today, well, that torch has been passed to modern astrophysicists and computer scientists who are using wildly complex mathematics and quantum mechanics to ask the exact same thing. So let's clearly define what we're actually investigating in this explainer today, the simulation hypothesis. It's the proposal that our perceived reality is actually a comprehensive computer simulation created by a more advanced civilization. Now, we're not talking about some simple, clunky 8-bit video game here. We are talking about a simulation so incredibly high resolution, so perfectly coded, that its inhabitants, meaning us, you and me, have absolutely no idea we're living inside a machine.
And this whole concept, it's completely moved out of the realm of pure philosophy and straight into serious academic research. Scholars at institutions like DePauw University are actively mapping out the growing field of simulation theory. We're talking serious philosophers, physicists, and scholars actively debating the statistical probabilities, the ethical implications, and the physical constraints of a simulated universe. It's wild stuff. When they debate this, they generally break it all down into two main models. On one side, we have what you could call the Matrix or RPG style. This is where pre-existing conscious minds, think of a brain literally sitting in a vat, are plugged into a simulated world. So you are real, but the environment around you is completely generated. Then on the other side, we have the Sims or NPC style. In this model, both your consciousness and the physical reality around you are entirely generated by code. You're essentially a non-player character, and neither you nor your universe actually exist outside of a hard drive.
Part 1. Bostrom's Cosmic Trailoma.
Now, to really grasp why academics take this so incredibly seriously, we have to look at a 2003 paper by Oxford philosopher Nick Bostrom. He basically mathematically formalized this whole thought experiment into 3 logical steps. Step 1. Humanity goes extinct before reaching a post-human stage where we'd even have that kind of massive computing power. Step 2. Post-human civilizations have absolutely zero interest in running simulations of their ancestors. And Step 3. We are almost certainly living in a computer simulation right now. So the really crucial point here is this. If you believe humanity will survive to become a highly advanced civilization, and you believe we would use our supercomputers to simulate our history, well then, statistically speaking, the odds are overwhelmingly high that we're already in one of those countless simulations right now, rather than the original baseline reality.
Part 2. Glitches in the system. So let's just assume for a moment that we are in a simulation. How would we actually know? Let's put on our cosmic detective hats for a second and look for literal bugs in the universe's code. Take the number 299,792 kilometers per second. That is the speed of light. Now, when we look at classical physics, it honestly seems a bit arbitrary that there's this absolute hard-coded maximum speed limit in the vacuum of space. But think about this from a software engineering perspective. This behaves exactly like a hardware limitation in a computer processor. If an object tries to move faster than this, the mathematics required to calculate its position, mass, and energy literally approach infinity. The simulation just can't process the data fast enough. So what happens? The universe pushes back and literally slows down time for that object, a very proven concept called time dilation. This speed limit acts exactly like a maximum clock speed or bandwidth, effectively managing the rendering budget of our cosmic processor to prevent a total system-wide crash. And then we have this absolutely mind-bending glitch, the observer effect. In quantum mechanics, specifically the famous double-slit experiment, particles actually exist as a wave of infinite mathematical probabilities. They only snap into a definite physical reality when someone, or something, actively measures or looks at them. But why? Why would the fundamental building blocks of matter change their behavior simply because they're being watched? Well, modern video game developers actually use an algorithmic shortcut called occlusion culling. To save processing power, a game only renders the high-resolution geometry exactly where the player's camera is looking. The unobserved environment simply doesn't exist as physical geometry until you turn around to look at it.
Our universe appears to be using the exact same optimization shortcut to save memory.
I know, it's crazy, but the cosmic glitches just keep piling up. We've got quantum entanglement, where two separated particles instantly mirror each other, completely defying distance. In computer science, that behaves exactly like two instances of an object pointing to the exact same line of code in a memory bank. Then there's dark energy. It's an invisible force accelerating the expansion of the universe, and it acts remarkably like procedural generation algorithms, constantly stretching the boundaries of a digital map. And look at the fine-tuned universe. Fundamental constants like gravity and electromagnetism are balanced on an absolute razor's edge, exactly like sandbox variables dialed in perfectly by a developer running multiple test builds. Oh, and finally, the holographic principle. It's a theory in astrophysics suggesting our entire 3D universe is actually projected from 2D binary data on a distant boundary, exactly like a 3D video game rendering from a completely flat computer screen.
But this right here might actually be the closest thing to a smoking gun we have ever found. Theoretical physicist Sylvester James Gates was exploring the wildly complex mathematics of superstring theory, looking at the equations that describe how quarks and leptons interact. And buried deep within that foundational math, he found embedded error-correcting computer code. And I don't mean just a metaphor for code. These were doubly even self-dual linear error-correcting block codes invented by mathematician Claude Shannon back in the 1940s. It is literally the exact same binary algorithms software engineers use in web browsers today to prevent data corruption. I mean, why on earth would the foundational physics of our universe need data transmission error correction unless the universe itself is constantly calculating, updating, and running checks on its own binary data?
Part 3. The Skeptics' Pushback.
Now, as compelling and, frankly, terrifying as these clues are, we definitely have to look at the other side of the argument, because not all scientists buy into the theory. Theoretical physicist Sean Carroll points out a really major flaw in the simulation logic. He knows that the laws we observe just don't look like a competently programmed simulation, because they have a lot of hidden complexity. Basically, skeptics argue that when you really dig into physics, you find a massive amount of hidden, completely unutilized structure. If you're programming a simulated world to save computing power, why on earth would you waste precious memory rendering completely useless subatomic complexity? And furthermore, the laws of physics are heavily constrained. They're local and they don't randomly change in time or place. A programmed environment wouldn't actually need to obey those strict, rigid constraints. But there's actually another reason some scientists think we probably shouldn't dig too deeply into finding proof, and it is incredibly unsettling. Philosopher Preston Green has warned about what he calls the danger of finding out. If our universe really is a research simulation created by a post-human civilization, and we successfully prove it by finding undeniable glitches or running certain high-energy experiments, we might completely ruin the integrity of their experiment. Think about it. If the simulated inhabitants realize they are in a simulation, the creators might just decide the data is compromised and, well, pull the plug, resulting in our immediate termination.
Part 4. Does reality even matter?
Yeah, that danger of termination is a seriously terrifying thought. So let's pull back from the astrophysics, the quantum mechanics, and the looming existential dread for a second. Let's shift our investigation in this explainer to the philosophical and ethical implications of this discovery. Philosopher David Chalmers offers a surprisingly comforting perspective here. He says, because the circuitry and data in the computer the simulation runs on are real, simulated life is just as authentic as any other. Essentially, even if that warm, tactile desk in front of you is made of code instead of carbon, it doesn't actually invalidate your experience. Your consciousness, your memories, your relationships, the joy you feel, the pain you endure, they are all profoundly real to you. A universe constructed from computer chips and algorithms is simply a different kind of fundamental physics. It definitely doesn't make your life any less meaningful. Which really brings us to our final thought for this explainer. If you're really nothing but code inside a massive cosmic computer, do your choices still matter? If a highly advanced civilization programmed the initial parameters of your life, do you truly have free will? Or is every single decision just the execution of an algorithmic script? You know, whether we are carbon-based biological organisms forged by billions of years of evolution, or incredibly complex digital avatars running on a cosmic hard drive, the reality we experience is the only one we actually have. So, what are you going to do with your processing time today?